Good afternoon to one and all present here. And today's presentee is Lavanya Priyadarshini R, and she is a research scholar from SGP. Now she is going to present the topic battery management system in electric vehicle. She is currently in second year.
So I am going to present the topic battery management systems in electric vehicles. So this is the block diagram of an electric vehicle. So this electric vehicle consists of, from grid, here we are giving a supply to the EV, and this is the battery pack, and this converts DC to DC converter, and the DC converter give it to the DC loads, and here we have DC to AC converter. So from the battery pack we are getting DC, so it is converted into AC and it is given to the motor and it is given to the traction. So this is the normal engine, so where we put gas like petroleum or diesel. So this is normal engine and this is for the EV block diagram. So before that, here is the battery pack. So we are using battery management system for this battery pack. So definition of BMS. BMS is an electronic system that manages rechargeable batteries. It monitors the battery state, calculates the data, reports it, and controls the environment. So what is generally a cell? So the difference between battery and a cell is, normally we call it as battery, but the battery is arranging the cells together form a battery. So in EV batteries, a cell refers to a single electrochemical unit within a battery pack. So the single electrochemical unit consists of two electrodes, which is anode and a cathode and an electrolyte. So they are using separator to separate the anode and the cathode, and these cells are arranged in series or parallel to create modules, and ultimately we get the complete battery pack. So the single unit is called a cell. So this is a battery cell. This is a single unit, and this is a battery module. The single unit are connected to form a battery module, and the battery modules are arranged to form a battery pack. And here we are going to see the cell balancing. So before moving to battery management system, we have to know what is cell balancing. So the cell balancing ensures all cells have nearly equal voltage and state of charge. So we have to check whether all the cells have equal voltage and the charges are equal in all the cells. So if we not balancing means, if you are not balancing, that it leads to reduced battery capacity and safety risk and shorter battery lifespan. So what will happen if it is not balanced means, so one cell will be charged and other cell will not be charged. So if it is not equally charged, then discharge will also be affected, which affects the lifetime of the battery. So we have two types of cell balancing. One is passive balancing and other one is active balancing. So what is passive balancing is, if we use only resistors to balance the circuit, it is for passive balancing. So active balancing, we use capacitors, inductors and converters to balance the circuit. So what is the difference between the active and the passive balancing is, so in passive balancing, the extra energy from the cells is dissipated as heat using resistors. Here we are using only resistors to dissipate the heat. So in active balancing, actively transfers charge from high voltage cell to low voltage cells. So in passive balancing, so here it is dissipated as heat and it is wasted. But here it transfers the charge from high voltage to low voltage cells. So the advantage and disadvantages are given here. So simple and low cost, but it wastes energy and slower balancing. Here in active balancing, the process efficient, less energy loss, and the cost is more complex and expensive. So if we use simply resistors, then it is easy to decide. So this is the difference between the active and passive balancing. Here we have different cells. So cell 1, cell 2, cell 3 and cell 4. So active passive balancing, the extra charges taken out. So the resistor takes the extra charges dissipate as heat. So we have this amount of charge here. But here in the active balancing, so if it is more means then it is given to the another cell. So we get more charge than the passive balancing. So in active balancing we get more charge, here we get less charge in active balancing. After balancing, so which is better means active balancing is better. So the importance of battery management system. So it enhances the safety, it improves battery life, and it is essential in EVs and energy storage circuits, and supports fault prevention and energy efficiency. So what are the functional blocks in the battery management system is voltage or current sensors, thermal monitors, and SOC and SOH estimation, that is state of charge and state of health estimation, fault detection control, and communication modules. So these are the main functional blocks of the battery management system. So the battery management system consists of a software and a hardware unit where the cell balancing is conducted. So the BMS topologies are, so the types are centralized, distributed, and modular. So in the centralized BMS, one control unit is used, and in the distributed, so one controller per cell is used, and the modular, the combination of both the units. So this is the circuit for the centralized and the distributed. So here one center unit is used, but here they have used gateways for the distributed units. So this indicates a sensor, this is the actuator, and these are the links. So the BMS software architecture consists of a real-time operating system. It is used for the multitasking operations and manages the safety critical functions. So if the cell is not balanced, if any one of the cell is not balanced, then it will lead to fire of the cell, and it will affect all the battery modules. So the software architecture where the database is controlled by all the circuits like the simulation module, SOC, EC model, and electrochemical fault injection and the validation decision. So all are controlled by the controlled from the database. So in the BMS hardware architecture, the sensors for the voltage, current, and temperature are attached, and relays, microcontrollers, and it is interfaced with the vehicle or grids. So this is the hardware architecture of the battery management system. Here the master control, and we have slave. So the master control controls the battery modules. So the battery packs consist of different modules. So each battery module is controlled by the slave. So we have voltage signal, temperature signal, and voltage detection. So everything is detected here. The functionalities of battery management system. So SOC and SOH estimation, and overcharge discharge protection, mainly cell balancing and load management and data logging. So what are the main functionalities of the battery management system is it monitors, protects, and equal charge and discharge, it communicates, diagnoses, and it manages the data. So testing and validation. So it is for the SOC current voltage, and for non-functional unit it estimates the thermal, EMI, and cycling, and it complies with the standards. So the safety aspects of BMS is it prevents the thermal runaway and detects if there is any short circuit, and it ensures the temperature control. So mainly the temperature control is the main problem in the electric vehicle. So already we have heard linear burst in two-wheelers we have found. So it ensures the temperature control, it manages the voltage and current limits. So what is the environmental impact is it reduces the carbon dioxide reduction emission. So emission of carbon dioxide, and it optimizes energy storage use, and it reduces the hazardous discharge. So this is BMS in electric vehicles. So it controls the energy usage, and it monitors the traction of the battery and interfaces with the electric vehicle systems, and it supports both charging and discharging. So this is the BMS in electric vehicle. So we have battery management system. It controls all the unit of the battery. So it senses the temperature, everything. And we have the from pedal. This if we press the pedal, it is going to the electronic control unit and it is going to the power converter. So the converter converts this DC to AC and it is sent to the motor. So there the mechanical drive is happen which rotates the wheel. And this battery also gives supply to the air condition sensing and other. So here the battery management system in stationary storage. So that is in electric vehicles. Here it is in stationary storage. So it manages large scale electrochemical stationary storage. It maintains voltage stability and it supports renewable energy integration. So here how they have used battery management system in stationary storage like in substations. So what are the challenges in current battery management system is? So that is limited state of charge and state of health modeling and inadequate data logging and lack of interoperability and need for standardization. So it is difficult to connect all the circuits. So if we implement BMS means all has to be synchronized and that is little difficult. And conclusion and recommendations. We have to focus on the construction of the battery management system where the passive circuit is easy but active we have to design accordingly. And the operational parameters, integration, installation and you have to implement new safety standards.